Thank you very much. This is Robin DeYoung from EPA, and I want to thank everyone for joining us today for the EPA's joint state and local energy technical forum on EPA's eGRID, the Emissions and Generation Resource Integrated Database. And before I get started, I'd like to turn it over to our facilitator, Catherine Morris, for a few instructions.
Thank you, Robin. This is Catherine Morris with the Keystone Center. I'll be facilitating the Q&A sessions of this webinar. It's our monthly State Climate and Energy Tech Forum. I wanted to just remind those of you who may not have participated before on the State Tech Forum, we use GoToWebinar technology, and it allows you to interact with our speakers by typing in questions to the question box. So I would ask you that as our speakers proceed through their presentations, if a question should occur to you, please type it in. You obviously noted that you're muted. So this is the way that gives you an opportunity to find out how their experience relates to what you're doing and maybe ask more specific questions about their presentations. What I would ask you to do is wait until, we won't actually get to your questions until the end of each speaker's presentation. So at that time, we often are not able to get to all of the questions. We'll hold off some of them until we get to the very end of both speakers, and then we'll have about 15 minutes of discussion. One of the first questions we always get is, where can I get the presentation materials? Please, and I'll type this into the chat box so you have the address, but if you haven't already downloaded the materials, they can be found at www.epatechforum.org. And I will, again, type that into the chat box so you have that access and you can get that information. You can download the presentations now or after we close out the webinar. I think that should have everybody in good shape to start with our presentations, Robin.
Okay, great. So before we start off, just a little mention about eGRID and its importance and why we decided to talk about eGRID for this tech forum today. eGRID is maintained by EPA, and it is a globally recognized source of emissions data for the electric power sector in the United States. And both state and local governments could use this information found in eGRID to achieve clean energy, climate, and air quality objectives, such as developing a greenhouse gas inventory of indirect emissions from electricity purchases, to estimating avoided greenhouse gas emissions, criteria, air pollutants, and mercury emissions as a result of clean energy policies and programs. So for our presentation today, Art Diem from EPA will walk through the wealth of information found in eGRID. And then I will show how state and local governments have applied eGRID to analyze the emission impacts of a state energy efficiency resource standard, a regional greenhouse gas inventory, and a local energy efficiency program. So now I'll transition into introducing our first speaker, Art Diem. Art has been with EPA for 10 years, and he currently works in the U.S. EPA Clean Air Markets Division. He's been managing the eGRID database since 2006. Prior to his tenure at EPA, Art worked at the New Jersey Department of Environmental Protection Air Program, serving in a regulation development capacity. Art earned a Bachelor's of Engineering degree from Stevens Institute of Technology in Hoboken, New Jersey. Go ahead, Art.
All right, thanks, Robin. Good afternoon, good morning, ladies and gentlemen. I'll be going through details about eGRID. Basically a database of power plants, air emissions, generation, and resource mix. We've stitched together a bunch of information from many sources, from EPA, from EIA, and a lot of this information is very difficult to put together. So I'll go through a bunch of details and go through a walkthrough. Okay. So we've got three related tools. First is eGRID. It's a database. We have data for emission years 1996 through 2000, 2004, 2005, and 2007. Those are the only years of data we have published as eGRID, though a lot of the source data does exist for these missing years, but they're not put together. eGRID Web, that's something we put together recently. That's an online application that lets you go through the data without having to slog through the spreadsheets. And Power Profiler, and that's an online application that lets you find your eGRID subregion. Basically, you pick a zip code, you enter a zip code, pick a utility that serves that zip code, and then the application will display eGRID subregion emission rates and resource mix for your area of the country, and let you do a few extra things as well. So eGRID began in 1998. It was developed by Rick Morgan. E.H. Peck and Associates has been the contractor doing the legwork for all the years of eGRID. eGRID Web we put online in 2009. It was a much-needed user interface to help improve accessibility. And Power Profiler began back in 2003 and was updated a bunch of times. So talking more about the data sources that go into eGRID, we get our information from the Clean Air Markets Division, from EIA. From the Clean Air Markets Division, we've got about 1,500 plants that submit hourly data to EPA. And for eGRID, we sum all this up to the ozone season for NOx and each year for an annual period. Most of this information is based on continuous emission monitors, or CEMs, although some of the information reported is gathered from other measured and monitoring devices. For example, oil, gas, fuel flow, measured fuel characteristics, and for certain low-emitting units, the default emission rates are used in there. So we also get a vast majority of information from EIA. We've got about 5,200 plants in the current edition of eGRID. So these are all the additional plants that don't report to CAND, all the non-emitting plants, all the plants that are too small to fit in these regulatory programs. And all this is surveyed information. There's no specification on how the information is gathered, collected, measured, monitored, reported. It's just basically surveys to EIA, but it's very extensive on the electric power sector. So for plants that we don't have Clean Air Markets Division data, we use EPA emission factors based off of their fuel and reported control devices, et cetera. We have all this documented in excruciating detail in the eGRID technical support document, and advise looking at that for more details. Basically, the data is set up in 3 different spreadsheets. This is the current year. Actually, the first one should say plant instead of aggregation there. So basically, we have plant level detail at the plant, boiler, and generator. We have an aggregation sheet that has all the other files, and then we have this other state import-export file as well. We've got a lot of PDF documents. Again, I mentioned our technical support document. There's a lot of summary data on there. So if the spreadsheets are a little intimidating, a lot of useful information is on the summary data, not at the plant level, but at some of the other levels of information. Our eGRID subregion greenhouse gas emission rates are in a one-pager, and we have our representational maps of some of the grid boundaries. I mentioned our user-friendly application, eGRID Web. Right now, that still only contains the 2004 and 2005 data. We hope to get 2000 up sometime. I just want to note, this is something that trips up a lot of people. The name of the eGRID edition, eGRID 2010. The 2010 is referring to the set point of the industry structure. We update companies. There was all kinds of mergers and buying of power plants. So we have this industry structure current up through 2010, even though the emission and generation year is 2007 in this case. All right, jumping into the data elements, we have a bunch of plant identification, location, We have a county centroid flag for the lat long coordinates that are based on a county centroid. Some plants we have their actual coordinates, other plants we don't. And once we don't, we'll use a county centroid. The owner and operator information is very useful. There's one operator at each plant and up to 16 owners, any of which may or may not be that operator. So, and we give percentages of ownership as well. So that's an interesting feature, and some other plant capacity and other plant information. We have some flags about whether it's a combined heat and power plant. If it is, we have some further information on that, whether it burns any biomass or landfill methane or pump storage facilities. We have those flags. We have a flag if it burns any coal. Then, of course, we have a key part is the emissions information. All the data years have NOx, SO2, and CO2. We added mercury in 1998, added methane and nitrous oxide, two other greenhouse gases from combustion in 2005. 2007, this most recent edition, we did the math for the CO2 equivalent, and also we took out the mercury data because it was the basis for that was very old and it wasn't as accurate as it used to be. We have all the information is based on the emissions associated with electricity generation. So we do some adjustments of emissions. So we also explicitly have unadjusted emissions listed there. For example, CHP plants, we split up the emissions between electricity and useful thermal output. And the electricity is, the main number that we have, but we in some other fields we show what the total emissions of the plant is as well, and that's the unadjusted emissions. Of course, we have net generation and heat input. Net generation can be negative. Basically, if a facility uses more electricity than it produces, they'll have a negative net generation. And in that case, you'll see some negative output emission rates. So if you see that, it's initially it won't make sense, but that's only in cases when the net generation of the plant is less than zero or it's negative. The input emission rates, heat input is always positive, so you'll never see a negative heat input emission rate. The combustion output emission rates are useful for plants that are like maybe part nuclear, part coal, and so you'll see the output emission rates from just on the combustion part as well. We have resource mix. Basically, we put the generation by resource type together. We have that at megawatt hours and percent. And we have a eGRID plant sequence number. That's useful when trying to link plant information from different years. Sometimes the plant names change. Sometimes even the ORIS plant code will change. It shouldn't, but in rare cases it does. So we have this to help link the plants between different years. On our unit level data, we have a little bit of boiler level data. That's mostly emissions and heat input. We'll have generator level data, mostly just generation. Those two are not linked together. It's very difficult to link those together on a unit-specific basis, so we link them together basically starting at the plant level. So if you go into the boiler level or generator level data, those aren't necessarily going to add up to what the total facility is, just because sometimes we don't have unit-specific data and we have to use prime mover level data. Then on the other side of the plant level, we'll take plants and we'll bunch them all together. So we'll take all the plants, make a U.S. total. Any plant that's located in each state, we'll basically aggregate those together. So we'll do it at the state level. We do aggregations at 3 different grid region levels. So I'll talk about that in a second. Also, we do company level aggregations. Company, the electric generating company, or EGC, both at the operator and ownership level of each of the plants. And then we also look at parent companies too. We've spent a lot of research on what the parent companies are. So when I talk about the different grid levels, in the continental U.S., there are 3 interconnections. Basically, in each of these interconnections, all the electric generators are synchronized with each other, and basically it's kind of difficult or expensive to transmit power outside of those synchronized interconnections. So we have the eastern grid, the western grid, and ERCOT. There are some AC-DC ties between them that allow a little bit of power to go, but generally electricity can pretty much freely move within each of these interconnections. So the first grid level that we use in eGRID is the NERC region level. NERC is North American Reliability Corporation, formerly Council. They oversee the reliability requirements for each area of the country. And so basically these are the NERC regions. They're established by NERC, and we aggregate plant level data up to the NERC region in eGRID. We've developed eGRID subregions. These are subsets of the NERC regions, except for ERCOT and Florida there. And one level below that, these are the power control areas, also sometimes known as balancing authorities. This is the level at which load or demand is balanced with generation. That is the level at which power is dispatched. So each of these power control areas can meet demand within its area by dispatching generators from within its control or calling on imports available from neighboring power control areas. So this is where the dispatch level happens. This is a rather old map. The new PCAs are not quite this list here, but gives you an idea of what those are. So within the aggregation level data, we have many of the plant fields, plus we have input and output emission rates gathered on fossil, coal, oil, and gas plants. And so basically, we look at a plant's primary fuel. If it's oil, we're going to put it in this oil category. It may burn a little bit of gas too, but we're throwing that in the oil category. And we've also, in the aggregation levels, we have a non-baseload output emission rates. Basically, these are a refinement of fossil fuel output emission rates that people were using when they were trying to figure out a good estimate of what happens when you reduce the demand for grid-supplied electricity. Basically, we go into detail about how we put this together in the technical support document, but basically we take out the non-combustion units within a region, look at the capacity factor of different plants as a surrogate of dispatch. It's basically akin to a deep marginal emission rate. So about the emissions in eGRID, we're not including any life cycle emissions, extraction, processing, or transportation fuels, just what's going up the stack. The actual values within the eGRID database do not include transmission distribution line losses. They're generation-based, so they're looking at the generators within that area and not accounting for imports and exports into and out of a particular area. And if you want to account for line losses for things like saying, okay, I used a certain amount of consumption, what does that mean as far as generation is concerned? We have gross grid loss factors, and we add them most recently to the summary tables. And so here's an equation to get from consumption to generation for that. Here's the illustration of the CO2 equivalent output emission rates in pounds per megawatt hour. So we get all the plants, look at all the greenhouse gas emissions, all the generation in each of these areas, and just do the math. So you can see the values range very greatly, and that's due to fuel mix. If there's a lot of non-combustion resources going on, like in the Pacific Northwest, you're going to have a lot lower CO2 output emission rate. I really show this. This is the eGRID subregion level. This is the level in which we try to strike a balance between areas that are way too big. So if you consume electricity in an area, we're trying to characterize the indirect emissions from that. You don't want to pick the U.S. total. That's a little bit too big. There's a lot of generation that really isn't affected by what you're doing in a particular area of the country. And we don't want to pick an aggregation level that's too small where you're ignoring a lot of importing and exporting. So this is the aggregation level where we try to strike that balance. Okay, so new this year in eGRID, we have some new generation-based plant primary fuel category. For example, if you had a facility last year in the last edition that was part nuclear, part coal, we're looking at plant primary fuel based on heat input. Nuclear has no heat input, so that was listed as a coal facility, even though the nuclear part may be generating a lot more. So we added a new plant fuel category based off of generation. We are more explicit about the biomass adjustment that takes place. Basically, for biomass, we adjust the CO2 emissions down to 0 on the premise that had the electricity not been generated from the combustion of this biomass, the biomass would have otherwise decomposed into greenhouse gases anyway, and it's a net 0 there. That's been a kind of policy and adjustment in eGRID since pretty much the beginning. We did a refinement of the coal flag, and we added the CO2 equivalent, so we did the math for you on that. Let's see, we added a lot of lat-long coordinates for a bunch of new plants. The new electric generating company type is either going to be non-utility or investor-owned utility, federal, state, political subdivision, municipal marketing authority, or co-op. And we're using a lot more CAMD data than we used to. We used to use just the acid rain program plants, and we're using a lot more. As far as uses and users, here's eGRID Power Profiler. The circles close to those are a lot of EPA tools that use the eGRID data from Energy Star Portfolio Manager, Climate Leaders Protocols, Personal Greenhouse Gas Calculator, Greenhouse Gas Equivalency Calculator, a lot of stuff out there. But beyond EPA, the big use of this is for carbon footprinting, greenhouse gas registries and inventories, including the Executive Order 13514, which requires federal facilities to there.
Art, I don't know if others are having problems, but I'm having difficulty hearing you. You seem to have lost your audio.
Okay, let's try this.
There's a lot of static on the line. It just started momentarily.
Okay. I don't know where that's coming from. I don't think it's coming from us.
Okay. Well, there you are. You're back.
Okay. So the all right, here we go. So we got a lot of academic, NGO, and consultant research on this. A lot of state and local governments use the information for various purposes. Environmental disclosure, certificate tracking systems, basically an emissions component for detailed dispatch models. There's a lot of uses. I'm not even aware of everything that it's being used for, but it's a really rich data set used for a lot of things. So pointing to the primary use that I'm seeing out there for inventories and for estimating emission reductions from clean energy projects, definitely recommend reading this paper here. We recommend using the eGRID subregion level output emission rates. If you want to include the transmission distribution losses, please go ahead and do so if you want. And if you're looking at carbon footprinting or inventories, we recommend using the total output emission rates. And if you're doing a void emission calculations, we recommend the non-base load. That's the short of that paper. So what's next? We're already starting on the next edition of eGRID with 2009 data. We're going to skip over year 2008. We have the data. We're moving forward, and pending any budget problems, we should get it out within a year or so. The eGRID web application, I really want to update that with year 2007 data, the current, but right now there's a lot of budget uncertainty, so I don't know when that's going to happen. Okay, I can go through a very brief walkthrough of a few things. Okay, here's the eGRID web page. Just to get all the files are here on the bottom. If you pull this first file here, that's everything. And if you want to selectively pull pieces of the data here, you can go ahead and do that. We have a link to the eGRID web application. We have frequently asked questions. Definitely recommend looking there, or the TSD if you have a real question. We have the archived edition of eGRID. This is where the 1996 through 2000 data is located. But back on the home page, this file will give you the 2004, 2005, and 2007 data. We have a feedback page. If there are things you like about eGRID, if you want to tell us what how you're using it, there are things that you don't like. If you have questions, if you just want to sign up to get updates, please use this. I'm definitely looking for good examples of people using it, and good feedback on its use, that you like to see it, you find it a valuable resource. If that's the case, feel free to send that in. So back to the home page, we have the quick links here. Here's the all files. Here's our greenhouse gas output emission rate page. So that has the information on a sub-region level. That's your one pager. We have the summary tables here. This is about 12 tables of summary information at aggregated levels. And here's the paper I referred to, as well as a technical support document. Now, when you look at the spreadsheets, like I mentioned, there are 3 basic spreadsheets here. There's a plant aggregation and a state import-export file. They might be a little intimidating at first for those who aren't used to big spreadsheets, but we have a table of contents here. I definitely recommend looking at that. Here's the plant file. And you can go through it, and these are you can filter a lot of the different fields. So if you just want to look at all the plants within Alabama, you can do that. You can come over here and say, oh, I want to see just the combined heat and power plants. You can do that. So, there are lots of ways to look through the data here, but it is a lot of data. It goes out to column, FF, so it's a lot of columns of data. It's hard to see a plant all at once. So that's why we created the eGRID web application. Like I said, it only has the 2004, 2005 data, but you can toggle between the two. If you want to look at a power plant, you can view the data. You can look at the emissions, generation resource mix, other characteristics, ownership, the different boilers that might be there, and the different generators. So there's lots of really great filters here. One thing that you can filter here at the plant level is you can filter on company level, company data. So if you have and this is really hard to do in the spreadsheet, you say, okay, I want to know all the plants that are owned by a certain company. we'll say here, and a lot of these are front companies too. So we've taken all the AES plants and put them all together. So that would be hard to do. Okay, let me go back here to the eGRID page. Let's see, what else was I going to talk about? Oh yeah, let's go to the Power Profiler site really quickly. So the Power Profiler site, you just put in your zip code, pick a utility that serves that zip code. I'll give you the eGRID subregion information for there, the fuel mix and compared fuel mixes for that subregion in blue, the U.S. average is in green, the emission rates, and then you can go and look at your emissions and put some consumption information, and it will give you the emissions there. Another really interesting site that a company out there did, the company SAP has an interesting platform where they can take lots of information and kind of let you slice and dice it. And they basically came and took the eGRID data and put it up in a pretty user-friendly format. So here you can look at state-level data. You have the resource mix here, emissions, renewable versus non-renewable. And so you can look at the different states, look at what's going on in the different subregions, and also at the NERC region level. It also has a more detailed reporting function, so you can go in and look at plant level data, any of the aggregation level data, and really slice and dice it very quickly and easily. And this should be up with, they said they're going to put the 2007 data within the next week or so. Let's see, did I miss anything in my walkthrough? I think that's just about it. So I'll open up questions right now.
Well, we have quite a few. A couple just clarification questions regarding some terminology. Control areas. You talked about that as one of the regions that you can find the eGRID data aggregated. Is that the same as the RTO ISO level of data? Is it like NEPL and, ISO New England or PJM?
In a lot of cases, the power control areas are ISOs or RTOs, but in some cases, they in parts of the country don't have ISOs, so to speak. But those are the areas where there's dispatch going on.
Okay. Also, wondering, question is whether or not you have the carbon data is based on fuel type or continuous emission monitoring data?
Repeat that question. I didn't quite catch that.
So are the carbon emissions data in eGRID based on fuel type, calculation based on fuel type, or are they based on CEM data?
Where we have CEM data, we use it, and we'll use that first. If we don't have CEM data or we don't have the data submitted to CAMD, then we'll take the EIA fuel use and use the greenhouse gas emission factors per the U.S. greenhouse gas inventory that's using the IPCC methodology. So we'll base it off of fuel use if we don't have the emissions report to us directly.
How does EPA recommend handling emissions for a customer who is connected to the grid but also has a power purchase agreement or power coming from a on-site distributed generator or EGC?
Yeah, definitely if the the eGRID emission factors are basically for generic power. If you have a source of electricity that you know of, and you know it's specifically coming from here, if you're directly connected to a certain plant, you can use that. If you have on-site solar panels, you can basically call that zero. So this is basically in the absence of better information. Here's how to value generic grid-supplied electricity.
I wonder if you have advice for one of the participants who is asking what they should do when they need data on generators or power plants that have been recently added to the system, particularly when they're looking at questions like new federal emissions regulations and how they might want to use the data to meet, say, the transport role.
I'm sorry, I was having a hard time just hearing that.
The question is what advice you might have, or how can you use the eGRID system when you need to have data on plants that are newly added to the system. So you have new power plants coming into the system. That obviously isn't being captured on the most recent data in eGRID. How would you advise states that are trying to do analysis, say, on complying with the transport rule and need that kind of information?
Well, I guess there's two places to go to. If there's a new plant that's reporting to CAMD, you can pull the hourly emissions data from the CAMD website. That's epa.gov/air markets, and just go to data and maps on there. If it's a facility that's not reporting there, then you'll need to go the EIA data and pull from the source data, the EIA 860 and EIA 923 forms. So that will get you as most recently as they have reported there. That's probably a good place to start, although it won't be stitched together like it is in eGRID. You'll have to put the pieces together yourself.
Somewhat related question is, when would it be useful for somebody who needs the data to actually go directly to the utility or electricity distribution company to get more customized emission rates?
Well, anyone has the option of doing that if they feel that that's more advantageous, if that's more accurate representation. That's something we can't do in eGRID because we don't have access to all the wholesale power transactions that take place. A lot of those are very difficult to get, and it'd be hard to do the calculation even if we had them. So if you have more specific information from your utility, look at whatever greenhouse gas protocols you're using, see if that's an option for you. I think in most cases the eGRID information is default. You have better information on top of that, and that kind of falls into that category.
Does the power profiler use total output or non-baseload output for its calculations? In other words, is it better for footprinting or for avoided emissions?
It uses the total.
We seem to be losing our audio again. I'm wondering if our operator can help by eliminating the static.
Moment.
Okay, that's all right. Yeah, can fall in there. We'll try a separate phone. If that's the problem.
So you think it's your phone, and we'll be able to. You're going to try another line. Well, while we're waiting for our speakers to rejoin, I know there's a number of other questions that we haven't been able to get to, and just to let you know, we will try to get to many more of them when they finish our second presentation. So everybody hold on. We're just waiting for our speakers to rejoin on another phone line to see if we can control for the static.
Sorry for that technical difficulty.
There you go. It sounds great now.
Okay, so so yes, we use the total output emission rates for Power Profiler. That's more of a more of like an inventory context than an avoided emission rate information.
Okay. Two more very quick questions. Does eGRID go to a monthly characterization of emissions?
No, we have, for NOx, we have ozone season, which is May 1st through September 30th, but that's as detailed as we get as far as a timeline. Otherwise, it's annual emissions.
And one more, the spreadsheets that are on the website, the eGRID website, are those downloadable?
Yes, they are. Yes, they are. The eGRID website, which has the new data, basically, I showed that's epa.gov/eGRID. You grab basically the all zip file, and zipped in there are all the spreadsheets. If you go to the eGRID web application, which has the 2004 and 2005 data, you can select whatever you want, and then you can export and print those as well.
Okay, well, we do have some more questions, but I'm going to hold on to those until after Robin has finished her presentation. We might have a chance to come back to them.
Thank you. Oh yeah, let me introduce Robin. Okay.
Okay, great. Thanks, Art. I'm assuming everyone can hear me. So my name is Robin Dion. I work in the State and Local Climate and Energy Program. I started at EPA in January 2010, and I work with state and local governments, helping them with technical assistance and quantifying greenhouse gas emissions, criteria air pollutant emissions for different projects. So today I'm going to talk about two different examples, how state and local governments have used, and really touch on how state and local governments have used eGRID for specific analysis. So first I'll discuss how EPA has helped New Mexico estimate the energy and emissions impacts of an adopted energy efficiency resource standard. Then I'll show you how the Delaware Valley Regional Planning Commission has quantified their greenhouse gas emissions related to their electricity consumption for their regional greenhouse gas emissions inventory, as well as their electricity reductions from their LED change out program. So right now at EPA, we're focusing our resources to help state and local governments incorporate energy efficiency and renewable energy policies and programs into their state implementation plans. And a while back, New Mexico expressed interest in learning how to do this, particularly for the upcoming ozone air quality standards, expected to be finalized this summer. So EPA staff from Region 6 and headquarters in the Office of Air and Radiation, we all came together and to start providing technical assistance to New Mexico. And one of the first steps in the process is to estimate the potential magnitude of emission reductions that they could account for in their forthcoming ozone SIP. I should note that it's unclear which areas in New Mexico, if any, will be designated non-attainment for the new ozone standard until the rules finalized. So this effort is really just to help New Mexico be prepared prior to final rule promulgation. We've been analyzing multiple energy efficiency and renewable energy policies and programs with New Mexico, but for today, I'm going to focus on New Mexico's energy efficiency resource standard. And in 2008, New Mexico adopted the Efficiency Use of Energy Act, where in House Bill 305, it requires investor-owned utilities to achieve a 10% reduction from 2005 total retail electricity sales by 2020. And it was really important for us to refer, it's always important to refer directly to the Energy Efficiency Resource Standard statute and any regulations that came out of that. And that helped us start putting together the pieces to estimate the energy impacts from the law. And we highly recommend in all cases to getting in touch with your public regulatory commission at the state level if there are any uncertainties or nuances within the law, and to ensure that you have correct assumptions. And it's good to build those relationships. So the next slide is I'm going to do a tiered approach on how you would estimate the energy impacts, or how we estimated the energy impacts of New Mexico's Energy Efficiency Resource Standard. So first, we identified the affected entities. It's important to know which utilities are subject to the rule. And in this case, based on the last slide and the rule, how the rule is read, investor-owned utilities were the affected entities. There are normally three main categories. There's the investor-owned utilities, municipal utilities, or cooperative utilities. Next, we identified the investor-owned utilities that were located within the state, and these are the three investor-owned utilities that we found. This information could be found from the Public Regulatory Commission, the Energy Information Administration, and eGRID has that information as well. For step 2, we identified the base year for which the law refers to, and this will be the baseline year we obtain total retail electricity sales. So 2005 is that base year, and then that moves us to the next step, step 3, to from 2005, we obtain the electricity sales for each of the investor-owned utilities, which you can see directly below each of the utility names. And the total utility sales in 2005 from these three investor-owned utilities was 12.9 million megawatt hours. And I provided a source here on the left-hand side where you can easily do a lookup on an EIA on their tables. So, and then the last step is really just easy math, where you take 10% of the total retail sales in 2005 and estimate the savings we should expect in 2020, which is 1.29 million megawatt hours. So basically, we took the rule and the statute, and then we applied how it was applicable, and we came up with these estimated energy impacts, or electricity savings that we should see in 2020. So now that we have the electricity savings resulting from the Energy Efficiency Resource Standard, the next step was to obtain emissions and plant information from eGRID. And what we found is, as we mine through eGRID, is that there can be multiple plants generating electricity for each investor-owned utility. And what I really liked about eGRID is that it's very easy to drill down from the operator-owner level all the way to the point of to the unit level at the boiler level. So for this analysis, we looked to see if all of the plants that were connected to the investor-owned utility, which eGRID subregion they were in. And we found that every plant that these IOUs used to operate electricity are all in the eGRID subregion AZNM. Sorry, that should be NM, not MN. And there's one plant, Luna Energy Facility, who is not in this subregion, but just for simplification purposes, since we're only estimating the magnitude of emission reductions, we're just going to use one subregion for now. Okay, so these are the two different quantification approaches that I'll go through. The first is the eGRID subregion using the AZNM average non-baseload emissions rate. And you'll notice that we're using the average non-baseload emissions rate in this analysis because this rate more closely coincides with the power plants that would most likely reduce generation from the ERS policy, as Art mentioned earlier. Just hitting that point home. This is just an illustration to show you which subregion we're looking at for this analysis. Next slide is just a summary of the non-baseload output emission rate. And a little bit more detail about what non-baseload emission rates represent. It's the generation from all plants within this region that most likely would change generation as electricity demand changes in the region. And what it omits is that it does not have emissions from plants that generally operate all hours of the day because the operating costs are low and these plants are not suitable for responding to demand fluctuations. And those types of plants are generally called baseload plants. And I also wanted to mention on a side note that you can actually see a pretty huge difference between the NOx emission rates and CO2 emission rates. So I thought that was interesting. Okay, next slide is, now we're getting into the actual equation that we would use. We have all of the data. We have the electricity sales saved from the ERS. We have the eGRID emissions rate after we look through all the plant data. And we also, in eGRID, have a grid loss factor. So you multiply those together. I supply the units that you would use in this equation. And then I have an example here of how you would apply how you would get NOx emissions. So for the New Mexico ERS in 2020, we estimated that 705 tons of NOx emissions would be avoided as a result of this energy efficiency policy. And then on this slide is a table that shows how much total emissions would be avoided from the New Mexico Energy Efficiency Resource Standard in 2020. And these are annual numbers. So if you think about it, if you added up each year's savings from the beginning of the policy implementation to 2020, you'd even see more savings if you did it on a cumulative level or cumulative basis. And here I've listed some benefits and limitations to using the eGRID approach, the average non-baseload emissions rate approach. It's very, you can see here it's very easy, back of the envelope type estimate. The non-baseload output emission rates reflect the plants that would most likely get displaced through eGRID region. It is important to note that not all the New Mexico plants are included. You can't really do anything that in terms of future looking. We don't know what types of plants will be online or retired in 2020, so it is a static analysis. It doesn't show where the EGUs would be displaced, which would be important when we do go deeper for the SIP implementation. And eGRID, the approach assumes the New Mexico policy will affect all non-baseload plants equally. Okay, so now let's get into the other approach, which is an eGRID plant level data using capacity factors. And this is a little more of a rigorous analysis compared to the first example. So a capacity factor is an indicator for how likely a plant is to be displaced from an energy efficiency or renewable energy policy. And basically what it is, it's a ratio for how much a power plant generates within a given time frame compared to the maximum continuous generation capacity within that same time frame. And what eGRID does, it assigns annual capacity factors for each power plant, and it is also possible to calculate the capacity factors during the ozone season. You'd have to do that offline, but the information is there in eGRID to do. So you could have two different capacity factors, ozone season versus non-ozone season. It's especially important if we're looking at how New Mexico could use this information to comply with their with the ozone standards. And then below are two contrasting examples to help illustrate this concept a little bit better. So if an EGU or a power plant has a high capacity factor, for example, above 80%, then that could mean this plant is operating at least 80% of its maximum capacity. And it's pretty safe to say this type of plant is a baseload plant, where it won't fluctuate generation in response to changes in demand. And then on the other hand, at the other end of the spectrum, you also have EGUs or power plants with low capacity factors, below 20%, let's say. And that means that this generator is generating much less than its maximum capacity. And it is pretty safe to say on this side that it is one of the first generators to be displaced in response to lower demand on the electric system. So now that you guys have a better understanding of what a capacity factor is, I have this capacity factor rule of thumb, and then I've applied it to the plants that we identified as the ones that are affected by the energy efficiency resource standard. So on the left-hand side is a sample curve for relating generation displacement to capacity factor. On the x-axis is the capacity factor, and on the y-axis is the percentage of a plant's generation that could be displaced. And so you see that linear relationship. And then on the right-hand side are the plants associated with the investor-owned utilities, like I said. And I've lined them up based on their capacity factor, their annual capacity factor that I found in eGRID. And so this rule of thumb is an indicator to determine how much emissions could be displaced from each of these plants. And so based on this rule of thumb, you could say about the plants in the blue section could be 100% displaced based on as a result of the energy efficiency resource standard. And then the plants in the purple section would be displaced in a using a linear relationship to the capacity factor and the displaceability shown in the graph on the left. And then even though the San Juan plant isn't up to 80% capacity factor, we could say, that is the highest plant, so most likely that wouldn't be displaced. All the other plants would be displaced before that. It's really important to note that this is just for explanatory purposes only, and that a complete capacity factor analysis would include all plants within the multiple power control areas to properly capture the policy impacts within this electric grid. So this is a very simplified approach just to explain how the capacity factor could be used. And so what our next steps will be with New Mexico is that we'll be looking at a wider analysis of all the plants within the entire AZNM eGRID subregion, and that would be, getting closer to a more complete analysis. So I don't have any emissions here to show you. Just wanted to give you a feel for the capacity factor approach. And then I list out a couple of different benefits and limitations of the capacity factor approach using eGRID. For example, emissions could be assigned to each power plant after you get all the capacity factors lined up. So you would figure out how much generation or how much savings would happen. You have, the 1.2 million megawatt hours of savings, and then you start assigning the amount of savings to each of the different plants, and then you could figure out how much emissions would be reduced for each plant. It's relatively easy to calculate this if it takes a little time to set up the infrastructure, but after that it's fairly easy. This is still considered a simplified approach, assuming that the power plants have the same capacity factor throughout the year, and then I said you could also get an ozone season versus non-ozone season capacity factor. It also doesn't account for maintenance or outages. Exported power is not considered here, which can be important depending on the area you're looking at. And also important to note, it assumes all energy savings or generation affects all the peaking units first, and it doesn't affect any of the baseload generation. And sometimes that's not true, when you look at, if you're just looking at lighting programs or like wind power, for example. So those are important factors to keep in mind when you're doing this approach. It is simplified, and there are some limitations. Okay, now I'm going to switch gears to a local example using eGRID. And the Delaware Valley Regional Planning Commission's Office of Energy and Climate Change Initiative, they lead, support, and coordinate efforts to reduce energy consumption and greenhouse gas emissions in their region. And right now they're supporting a goal to reduce regional greenhouse gas emissions 50% by 2035. So first I'll go over how they quantified the electricity consumption for their greenhouse gas emissions inventory, and then I'll move into the LED change-off program. So another eGRID subregion map that shows the area of analysis this time around. We're looking at the RFC East subregion. And on the right-hand side, lower right-hand side, you can see the total average emission rate that we're using. And so since this analysis, another note is that since this analysis was for 2005 inventory, these are the 2005 greenhouse gas emission rates. And we're using the total average emission rate so that we can capture emissions from all the power plants within the region. This is an inventory. And again, everything falls within one region, so it's a pretty clean approach. So to calculate the indirect emissions from electricity consumption, what DVRPC did is that they used these following equations for each greenhouse gas. And so for this approach, you'd get CO2, methane, and nitrous oxide emissions separately. You'd multiply the electricity consumption times the average eGRID subregion emissions rate, and you get your emissions for 2005. Alternatively, and unless they want to use or unless they want to use your the tool that does the CO2 equivalent for you, which is available for 07, right? But alternatively, if you don't have that option, or you want to do it yourself, you could calculate the CO2 equivalent of the greenhouse gas inventory. And sometimes this might be easier for a community to communicate the impacts of their inventory. So because then you only have one number, you only have one greenhouse gas emissions number. But you'll have to do some additional steps in the front end. So the general approach would be to multiply the emissions rate times, sometimes you need an energy conversion factor, and then you would multiply by a global warming potential. And I have the units here in the equation. I have some helpful conversions. And on this next slide, I give you the details of exactly how this would be applied. So to get the net emissions rate, CO2 emissions rate, that doesn't change. We're keeping that the same. And then for the methane and nitrous oxide, you would multiply you can see here, for example, for methane, you have the 30.3 pounds per gigawatt hour is their emissions rate. And if you want to turn that into megawatt hours, you need this conversion factor. And then you multiply 21, which is the global warming potential, and you get the CO2 equivalent emissions rate by doing that for methane. And then you apply the same method for nitrous oxide. And then after you get the equivalent emission rate for methane and nitrous oxide, then you add the CO2 emissions rate with the methane emissions rate and the nitrous oxide emissions rate. I applied the grid loss factor here, so it's 1 over 1 minus the grid loss factor to capture that loss. And in total, we have 1,224 pounds of CO2 equivalent per megawatt hour. So there's your net emissions rate. And then after you get that, you would calculate the total regional greenhouse gas emissions from electricity consumption. And DVRPC found through their analysis that there's about 54,000 gigawatt hours of electricity consumed in their 9-county region. And you go through the calculations, and you get 30.1 million metric tons of CO2 that are attributed to their region's electricity consumption that would be inputted into their inventory. So that's how you do. That's how DVRPC did their greenhouse gas calculations. And then lastly, we have a LED change-out program. And DVRPC estimated the CO2 savings from a region-wide LED program as a part of their application for an EPA Climate Showcase Communities grant in the summer of 2010. And so since this is a rough estimate of projected savings, the simplified approach was a good approach, and they just used CO2 emissions, and they didn't account for grid loss factors. So, if you're estimating things, you don't have to cross all your T's and dot all your I's. And here's what they thought would happen. Their goal is to change out 10,000 incandescent traffic lights for LEDs, and they're projected to save 3,000 megawatt hours annually. They use the non-base load CO2 factor because this is changing emissions, changing demand. And then they estimated, and this is how they estimated their CO2 emissions. And you can see the calculation below. So that's all I have on the different programs. And for the next technical forum, we are actually going to have a 3-part series that is going to take different pieces of the Assessing the Multiple Benefits of Clean Energy resource that EPA put out in February 2010. And so the first webinar is going to talk a little bit more about how the electrical grid works and a little bit more sophistication on how to get energy impacts from clean energy policies, how to figure that out. Then the next webinar we're planning will look at more complex emissions quantification methodologies as a result of clean energy policies or programs. So we'll do some more displaced emissions approaches. And then in the third webinar series, we'll have we'll show quantification methodologies or estimations of the economic benefits of clean energy policies and programs. So we'll touch on how to estimate jobs being saved or gained, money saved or avoided from these policies. And so we're hoping that looking at all these different benefits will help you in making the case for your clean energy policies and programs. We also have a survey at the end of this webinar, and it would be really helpful if you could answer those questions, and that will help inform us in getting the information that you really want and need in this next series. My contact information, and I want to thank everyone again for participating today, and I think we're ready for any additional questions.
Okay, Robin, we have quite a few, and I forwarded some for you to look over, but in the meantime, let me ask some of the questions that are coming in. A number of them are asking about how to make the determination about when you would use the base load emissions factors versus the non-base load emission rates. One gentleman has actually provided this very lengthy and specific example, but for instance, on the case study that you provided here, where you're looking at the LED lights and the reductions coming from that, can you explain a little bit more of the rationale behind why you did not use the base load, or you don't think it affects base load emissions?
Yeah, that's a good question. The reason why we use the non-base load emission rates is because it's more likely that the change in lighting will affect non-base load generators.
So it's, the reductions aren't so continuous over all hours that baseload plants would be affected?
Yeah, this is basically the the choice of the total output emission rate, which is the whole system mix. And in that system mix, there are some, there's a certain amount of baseload generation. There's generation that is happening, basically no matter what kind of variations in electricity load are happening. There's a minimum amount of load out there that's happening. All those generators are operating, and pretty much the rationale, I presume, is that these changes in efficiency, this new efficiency, is going to affect more of the non-baseload facilities and less of these baseload facilities, and that's why things got weighted that way, and that's how the non-baseload emission rate in eGRID is set up as basically a deep marginal emission rate, looking at what's happening at the margin, and is basically any nuclear plants that are running are going to keep on putting their output no matter what's happening on the demand side.
And also, it's just such a small amount of change that it wouldn't go deep enough to affect any of the baseload plants.
Thanks for that. Another question was whether or not the data is available at a county level. You gave an example in this last local area, and again, someone in our participant group is apparently in that area and said that's basically the greater Philadelphia area, your last example?
Right.
Well, some of the other participants are wondering if you can break it down to the county level if need be.
Well, yeah, I mean, you can start with consumption that's taking place at anywhere, a particular building, a group of buildings, a city, a county, a state, and one thing that we recommend is, just because you use, energy in a county doesn't mean that all the electricity is coming from there. So that's, again, why we, on the, quick and dirty estimate, why we recommend going to the eGRID subregion level of your county. So if you don't know your eGRID subregion, go ahead and use Power Profiler. Put in a zip code and pick a utility, and you'll find out what your eGRID subregion is.
Okay, thank you. Another question asks whether or not you have some advice about one of the limitations you mentioned. You mentioned that you can't, even with the capacity factor approach, necessarily assume that some of that power isn't exported out of the region. One of the participants wonders that, for instance, even after you've implemented an energy efficiency program and you have savings from that, how do you know that that power isn't then going to be exported to or provided to a municipal government contract or something else? So is there any advice you have about how to control for those types of limitations?
I think these are estimates, and there are some limitations there. If you want to really get into the details, there are a lot more complicated ways of putting this together. There are dispatch models that will account for things like that. Short of doing some really expensive analysis, this is kind of an easier and cheaper way of doing that gets you hopefully to a pretty close answer, or answer that is close to what you would have gotten if you spent a lot more resources on a more rigorous analysis.
I wonder, Robin, if you could take a look at Dave Alloway's question. He has a specific case study he's asking for your advice on. And maybe in the meantime, Art, I have a question that goes back to some of your presentation materials. One was, you noted that there was gaps in the data. In other words, you aren't covering every single year. You have some years that you've skipped. Can you just explain why?
I can explain. Year 2006, EIA didn't collect some data, and it made it really difficult for us to actually do anything with it. And so we had 2007 data ready to go, and I made the decision that it's better to go with a more recent year of data and start working on that than to fret over your 2006 data, which was missing a whole bunch of information from EIA. So kind of made the decision to go ahead on that. I think for the years 2001, 2002, and 2003, that was before my tenure. I understand there were some data issues that happened. Not exactly sure why those years didn't happen, but if you're really looking at some detailed plan information, you can go ahead to the CAMD website and the EIA site, and if you're only looking at a few plants, you might be able to filter out what you need from there.
Okay. Another participant is having problems separating the combined cycle generation from the boiler generation and would like to know if you have advice on how to handle that through the eGRID data.
Okay, combined cycle versus boiler generator. Yeah, so
combined heat and power, perhaps?
Yeah. There's a combined cycle system is where there's generally a combustion turbine and a heat recovery steam generator and an additional steam turbine. So those are reported different ways in EPA, in CAMD, and also in EIA. I think EIA will generally, from combined cycle systems, they'll have they have information on the prime mover level, prime mover fuel level in the 906, 920. I think combined cycle systems, they'll have CC as the code for the combustion turbine part of a combined cycle, and CA is the steam generation that happens there. And so they'll list the different prime movers. And that's where it gets really tricky with eGRID, is when we're trying to combine the information from different data sets together and try to match them up. And sometimes we see some mismatches, and we're like, okay, are those really the same unit, or are those, do they have different prime movers listed? Are there 2 units? Are they the same unit? So yeah, it does get very tricky, and I guess check the prime mover codes. And if you need help navigating the CAMD data, feel free to give me a call or send me an email, and I might be able to help you identify what kind of prime movers there are for the different units in the acid rain program.
Hey, Catherine, I can answer the question from David Holloway.
Okay, you want me to just read it, or you can paraphrase it?
Yeah, go ahead. Why don't you do that for the group?
Okay. Well, David's asking if about a particular kind of situation. He says, consider a case where a municipal utility has a different, specifically a lower greenhouse gas generation mix than their subregion. Say, for instance, they were getting more of their power from hydro. Using the subregion greenhouse gas rate doesn't really acknowledge the utility's decision to purchase from lower greenhouse gases, but using the utility-specific greenhouse gas rate would send a potentially misleading message that their electricity purchases are low carbon and we don't need to reduce use. So do you have advice for us on how to move forward? Would you use both some average? What approach?
Yeah, so one way that this community could move forward is, if you have utility calculated data for a specific plant and their purchases, then you can use that to show how you are what the greenhouse gas impact is from your purchases and generation in your community for your municipal power plant. Most communities don't have that type of information, and they don't have resources to get that. So that's when we recommend using the eGRID. That's the time where you would use the eGRID subregion emissions rate. And in terms of the perception of not needing to reduce your electricity consumption because you have low carbon generation, there are a number of different benefits that I think would resonate with people to get them to change their behavior and be more efficient in their energy use. I mean, you could talk about lowering your electricity bills if you use less electricity. You're also avoiding cost of new generation that could come down the line in the future. And we even have in our assessing the multiple benefits of clean energy resource, we talk about how certain clean energy policies can save or create jobs. So that's another factor that could be communicated. So those are some ways maybe that will help him in his question.
Thank you very much. Well, we're at the end of the hour, and we're also just about out of questions. We've covered most of the questions. And I just want to remind people that the contact information for both Art and Robin has been posted on the website that also has their presentation materials. So if you have specific questions, they've agreed to, I think we have both their phone number and their email so that you can get in touch with them directly. And they'll be happy to follow up with you. So with that, we're going to close this session, and just a reminder that you will receive the survey questions at the end. If you can just there's only a few short questions. It won't take you more than 5 minutes, so it would be very helpful in planning the next 3 sessions that are going to be on multiple benefits, and we'd appreciate your input. Thanks very much, and we'll talk to you again next month.